Let me ask you a question. Do you ever wake up, look at your news feed, and just feel like artificial intelligence is evolving so fast you're actually getting whiplash?
Oh, absolutely. Every single day.
Yeah, because if you're feeling that way right now, you are definitely not alone.
Welcome to the Deep Dive.
Hmm.
Today, we're opening up a fascinating and, frankly, paradigm-shifting presentation deck. It's titled The Autonomous AI Era.
And it really is a massive shift.
It is. So our mission today is simple. We are going to walk through this document step by step to understand the massive shift happening right now in technology. We aren't just looking at minor software updates here. We're looking at a fundamental rewrite of how digital work actually gets done.
Right, it's not just an iteration, it's a completely new baseline.
Exactly. Okay, let's unpack this. The deck kicks off with a massive claim. The heading here is, the industry has officially transitioned from chat to autonomy.
Yeah. And just summarizing the intent here, it seems we are moving way past Era 1, which is your basic chatbots, and moving straight through Era 2, those co-pilots, right into Era 3, which is autonomous agents.
What's really fascinating here is how the metrics for success have completely changed almost overnight.
How so?
Well, for a long time, the goal was simply generating conversational text. You ask a question, you get a highly articulate answer. But the new defining metric for AI success is the ability to take direct action without continuous human prompting.
So taking the training wheels off.
Basically, yeah.
Yeah.
It's the fundamental difference between an AI giving you a step-by-step tutorial on how to do something and the AI just going out into the digital world and doing it for you.
So it's less about talking to a super smart encyclopedia and more about handing off a complex to-do list to an invisible employee.
Exactly. And the financial signals backing this shift are staggering. Anthropic recently closed a $30 billion funding round.
Wow.
Yeah, that capital injection catapults their total valuation to $380 billion.
380 billion. I mean, that's astronomical. That is larger than the GDP of plenty of countries.
It is, but you have to look at the data. It's driven heavily by actual recurring revenue.
Yeah.
Their agentic product, which is called Claude Code, is already generating $2.5 billion annually.
Just from that one product.
Right. The capital is aggressively following the autonomy. Look at Meta. They just made a massive strategic appointment, bringing in a new AI chief with a $14 billion compensation and budget package.
14 billion.
Yeah. That level of aggressive capital deployment from the major players is entirely focused on one thing, pushing independent framework action. They know that the standard chat interface is already obsolete.
Which directly feeds into the next major argument in the deck. The slide title is Exponential AI Growth is Colliding with Physical Infrastructure Limits.
This is the bottleneck.
Yeah, and here's where it gets really interesting because we are transitioning from this boundless digital dream into the physical world where these massive computing ambitions hit a literal brick wall.
If we connect this to the bigger picture, the rapid scaling of these autonomous AI agents is currently bottlenecked by severe physical constraints.
Like what, specifically?
We are talking about aging energy grids and strained raw material supply chains. The Department of Energy put out a really stark projection stating that data center power demand will triple by the year 2028.
Triple in just a few years.
Right. Now, that alone is a massive engineering challenge, but here is the kicker. 70% of the infrastructure on those power grids predates modern computing.
Wait, so we're trying to run the most power-hungry advanced technology in human history on power grids that were essentially built before the color television was widespread.
Pretty much.
That sounds like a recipe for rolling blackouts.
It is a critical vulnerability. And the tech giants know it, which is why they are desperately trying to build their own lifeboats.
What do you mean by lifeboats?
Well, Google right now relies on over 100 million lithium-ion battery cells strictly to sustain their data centers during grid instability.
So they are literally hoarding local power storage just to keep the servers humming when the aging grid flickers.
Right.
But hoarding batteries brings up the second physical limit mentioned here, which is the raw materials to actually build those batteries.
Precisely. Morgan Stanley forecasts an 80,000-ton lithium shortfall this very year.
This year.
This year. And total global demand is expected to jump 5 times by 2030. Resource extraction technology isn't just a separate blue-collar industry anymore. It is entirely critical to AI survival.
Because you can't have autonomous digital agents without someone pulling lithium out of the dirt.
Exactly. The infrastructure squeeze is very real.
Which makes the shift in how we actually build this software even more important. Moving on, the presentation pivots to a new heading. Orchestrating outcomes is replacing traditional software syntax.
This changes everything for developers.
Yeah, so summarizing this, if you have a background in software development, or even if you just manage tech teams, the fundamental definition of software engineering is changing. Instead of humans writing intermediate code, developers will direct AI models to generate binary directly.
Yes.
Just to ground that for a second for you listening, binary is basically the raw ones and zeros that a computer chip actually reads, right?
Exactly. And this is a total paradigm shift. In the traditional model, a human writes code in language like Python or C++beg, a compiler, translates it, and you get your binary executable.
Right.
The new paradigm cuts out the middleman entirely. Elon Musk recently asserted that AI will skip the traditional coding process altogether by December, directly outputting highly efficient binary and bypassing human programming languages completely.
Okay, I have to push back on that a bit.
Hmm?
Elon Musk is notorious for aggressive timelines that inevitably get pushed back. Is there actual framework data in this deck to support that December target, or is that just classic industry hype?
That is a very fair point to raise. While the December timeline might be optimistic posturing, the underlying trend in the data is undeniable.
Okay.
The strategic value of a developer is rapidly moving away from syntax memorization. Knowing exactly where to put a semicolon or how to structure a specific loop.
Right.
It's moving toward system architecture and what the deck calls intent-based prompt directing.
Intent-based?
Yeah. Copilots that just help you type faster are yesterday's news. The industry goal now is building systems that execute the complete build process autonomously. You provide the clear intent, the AI agent handles all the underlying logic, and out pops the direct binary.
Which brings us to a really surprising revelation about how these AI models are actually being trained. The next slide argues that hyperlocal context consistently outperforms global model scale.
This is a huge shift in the strategy.
It really is. It feels like a classic David versus Goliath insight. The core intent here is that the massive global large language models we all know are actually failing at regional nuance.
And the data on this is incredibly rigorous. There is a regional AI startup in India called Sarvam. They conducted extensive testing across 15 different Indian languages with 35,000 native speakers.
That's a massive sample size.
It is. In those tests, Sarvam achieved an 87% accuracy rate. That is incredibly high when you consider the complex regional dialects, cultural slang, and linguistic nuances involved.
Right.
But here's the comparative data point. In the exact same test, OpenAI's massive global model achieved only 36% accuracy.
36%? That's barely functional. That's a failing grade by any standard.
It gets worse. The global model suffered severe hallucinations. In one documented instance, when it was prompted in Hindi, it actually output the response in Hungarian.
Wait, Hungarian?
Yes, it completely lost its geographical and linguistic grounding.
That's wild. It's like asking for directions to a restaurant in Mumbai and getting a street map of Budapest.
Exactly. What this proves is that specialized, localized training data is strictly superior in critical enterprise markets.
Because you can't just build one giant monolithic brain in a server farm in California and expect it to intimately understand the operational nuances of a specific regional market in India.
You can't. And this is why sovereign AI infrastructure is becoming a national necessity. India has explicitly recognized this, which is evidenced by a massive 10 lakh crore rupee pledge to build their own sovereign compute infrastructure.
Ensuring their AI actually understands their own context.
Precisely.
That need for specialization naturally transitions into how these localized, highly capable models actually execute their work. The next section's heading is complex problem solving requires collaborative multi-agent swarms.
Swarms. It's a great term for it.
Yeah. So we are moving away from you just typing a prompt into a single AI and instead deploying collaborative networks of specialized agents working together.
Think of it like a corporate organizational chart, but entirely populated by AI.
Okay, break that down for me.
The architecture relies on what's called a synthesizing leader agent. Underneath that leader, you have specialized agents taking on distinct roles. One is researching raw data, one is running mathematical models, one is strictly checking the work for logic errors.
So they divide the labor.
Exactly. And the leader agent synthesizes all of these debates into a final optimal output. A great example from the source material is xAI's Grok 4.20.
What are they doing differently?
For standard queries, it deploys 4 concurrent agents. But for complex enterprise tasks, It scales up to 16 simultaneous agents working on the problem together.
And the results of this swarm approach are pretty undeniable, looking at the data here. The deck mentions a specific face-off involving predictive livestock trading, which sounds incredibly complex. How did the swarm actually handle that?
It's a jaw-dropping example. In this complex arena, one agent analyzed global weather patterns impacting feed costs. Another agent looked at historical market fluctuations. A third agent proposed specific trades, and a fourth acted as a risk assessment auditor.
Just constantly double-checking the math.
Yeah. Right. The leader agent debated their inputs until they reached consensus. This collaborative architecture allowed Grok to defeat GPT-5 and Claude Opus 4.5.
In livestock trading.
Yes. And it didn't just win a simulated benchmark test. It executed trades that generated actual financial profit. By having multiple agents checking each other's blind spots, the reliability of the output skyrockets.
Wow. An AI swarm debating itself to generate actual profit in agricultural trading. That leads us to a massive structural change in the software itself. The deck points out something we've all probably noticed, that we're constantly bouncing between different apps for text, images, and code.
Right, the app fatigue is real.
But the next slide's heading states, fragmented tools are merging into centralized multimodal engines. What does that centralization actually look like in practice?
We are seeing the death of the specialized standalone application. Google's Gemini 3.1 Pro is highlighted here as the prime example. It has fully integrated specialized models. Specifically, it absorbed a model called Liria 3 for audio generation and another called Nano for image rendering into a single unified engine.
So you don't bounce between apps or tabs anymore.
You don't. And what's fascinating is the emerging capability. By combining these modalities into one brain, the core engine's reasoning capabilities jumped from a 31% to a 77% success rate on internal logic benchmarks within just 3 months.
A 77% success rate on complex logic is a massive leap. How does that translate to a tangible, real-world use case for you or me?
The document provides a perfect illustration of this deep logical processing. A user submitted a single text prompt. The multimodal engine processed that prompt for 4 minutes.
Which, by the way, is an absolute eternity in AI compute time. Usually you get an answer in milliseconds.
Exactly. But after 4 minutes of deep thinking, it generated a flawless animated SVG asset using over 30,000 tokens of pure code.
Just to translate that a bit for the listener, an SVG is a scalable vector graphic, meaning it designed the visual mathematically so it never gets pixelated. And 30,000 tokens is basically the equivalent of writing a small novel's worth of code, right?
Spot on. It designed the visual image, wrote the complex mathematical code to animate it seamlessly, and delivered a finished end-to-end asset, all within one centralized brain.
That's incredible.
It didn't just write code. It understood the visual, spatial, and temporal logic required to make it all work together perfectly.
Which makes our next heading feel like the inevitable conclusion of all this raw power. The presentation highlights that zero-touch agents execute closed-loop autonomous deployment.
Closed loop is the key phrase there.
Yeah. We are talking about development environments that now feature integrated AI systems requiring absolutely zero human supervision.
This is the operationalization of everything we've talked about so far. Let's walk through this closed loop. The cycle goes plan, build, launch Chrome, QA test, and fix bugs.
Okay.
It is an entirely self-contained workflow. Google has developed what they call an anti-gravity agent that operates entirely inside VS Code.
And for context, VS Code is the digital workbench where developers actually type and organize their software projects.
Right. Once you give this agent the initial project prompt, it requires absolutely no further human intervention.
I'm just imagining a developer typing in what they want, getting up to grab a coffee, and coming back to a completely finished, tested application. Is it really that hands-off?
Completely. The agent independently generates the implementation steps. It writes the full-stack code. Then it actually launches live internet browser instances to conduct human-like quality assurance testing.
It tests its own code in a browser.
Yes, it clicks the buttons, checks the formatting, and looks for visual or logical errors. Upon detecting bugs during its own self-directed tests, the AI switches back to the code editor, patches the issue, and retests the application.
Wow.
It runs this loop endlessly until the application is perfect, condensing what used to be weeks of painstaking human testing into mere minutes.
So what does this all mean? How does this cascade down to your daily life if you aren't writing software? That brings us to the next section. The heading is Consumer Workflows are Shifting to Operational Personal Agents.
This is where it hits home for the average user.
Exactly, because if we look at the friction in our daily lives, Legacy AI was essentially just an interactive instruction manual. You would ask, how do I change my shipping preferences? Or how do I book a complicated multi-city flight? And it would just give you a bulleted list of steps to follow.
Right, it just told you what to do. Agentic AI doesn't tell you how to do it. It executes the real-world digital logistics across multiple platforms on your behalf.
It actually does the clicking.
It logs into the portal, actually files the expense report, changes the shipping address, and reschedules the package delivery. For example, Claude Sonnet 4.6 is now autonomously navigating complex software interfaces just to process user to-do lists.
I think anyone listening would love an AI that actually clears out their to-do list instead of just categorizing it. I'm just imagining this thing trying to cancel a gym membership for me.
Good luck with that.
Right. If an AI agent can successfully navigate that intentionally confusing maze and actually get the gym to stop billing my credit card, it deserves a Nobel Prize, not just a massive valuation.
It's funny you mention that because the market demand for exactly that kind of real-world execution is extreme right now. The source material notes a recent intense bidding war between Meta and OpenAI.
Oh, for what?
They were fighting over the creator of OpenClaw, which is a WhatsApp-based flight booking agent. OpenAI's aggressive acquisition of this creator signals a major strategic pivot.
They want the execution capability.
Exactly. The major labs are prioritizing models that take actionable steps in the real world, because that is where the ultimate consumer value lies.
But anytime you introduce technology that takes independent action in the real world, especially at the speed, you run into serious friction. Which brings us to a heavy section of the deck. The heading states, accelerated institutional integration is triggering ethical fallout.
Yes, this is a very complex area.
Now, we are going to maintain a strictly objective look here and just report the data provided in the deck regarding this adoption pace and the operational risk. We aren't endorsing or criticizing, just looking at the facts on the ground.
And the data points to a massive, aggressive acceleration of institutional embedding. Traditional, highly regulated enterprises aren't just experimenting on the sidelines anymore.
They're all in.
They are deeply embedding these models into their core operations. For instance, Goldman Sachs has placed Anthropic engineers directly in-house.
In-house at the bank.
Yes. They are working shoulder to shoulder to manage strict regulatory compliance as the bank integrates these autonomous trading and analysis systems.
And the deck also touches on the defense sector, right?
It does. Military integration is moving incredibly fast. The text reports that Claude was utilized via Palantir during operations in Venezuela, which triggered high-stakes operational friction.
And there is a documented human consequence to this rapid pace of deployment, particularly among the people who actually build and monitor the safety of these systems.
Yes, the aggressive pace of defense and enterprise deployment has caused a measurable crisis among safety researchers. The source explicitly highlights that Anthropic's lead safeguards researcher quit the field entirely as a direct result of this accelerated integration.
That is a very stark data point.
It is. It is forcing a significant reckoning regarding safety, operational control, and value alignment within the industry, as these autonomous systems are deployed into life-or-death scenarios faster than the guardrails can be perfected.
That safety reckoning is going to be a massive hurdle. But whether we are ready for it or not, this autonomous era is arriving. So how do you actually navigate it? That brings us to the final section of the deck, which is essentially a survival guide for adapting.
We all need one of those right now.
For sure. The final heading is, organizations must transition to systems thinking and agent orchestration. It outlines a very clear framework of what to stop doing, what to start doing, and what to prepare for.
To survive this shift, organizations have to aggressively abandon legacy tech workflows. Look at the stop doing list. Leaders need to stop relying on manual coding for every project.
Makes sense based on what we just discussed.
They need to stop building workflows around single prompt chatting. And crucially, they must stop trusting off-the-shelf global logic for highly localized, nuanced regional problems.
And on the flip side, the start doing list demands a heavy shift in how we train and manage our teams.
Exactly. Organizations must immediately transition their workforce training toward system architecture and intent-based prompt engineering.
So teaching your team how to clearly articulate goals to an AI rather than doing the rote task themselves.
Yes. They need to start doing agent orchestration, essentially becoming managers of AI swarms. They must invest heavily in local context and localized training data. And teams should urgently integrate end-to-end multimodal testing, setting up those zero-touch workflows to automate their operational logistics.
Finally, the prepare for list highlights the macro challenges that could blindside you if you aren't paying attention.
Leaders must actively account for critical bottlenecks. They need to prepare for severe energy constraints by investing in secure energy solutions and smaller, localized models that don't require massive grid power.
Right, getting off the strain grid.
They must prepare for autonomous enterprise execution, where your competitors are moving at the speed of AI, not the speed of